Hello, I am Saurav Barua. Today I am going to present summary report on a research paper published in East Journal. The title of the summary report, the title of the paper was Large Scale Disaster Evacuation Choice Behavior Modeling Under Compound Risk of Natural Disaster Amid COVID-19 Pandemic in Japan. The paper was published in 2024. I'm Saurav Barua and I'm presenting to this paper summary. So firstly, understanding the research focuses on the evacuation decision-making behavior of people in Japan, and the situation is during the COVID-19, and the scenario considered here is large-scale flood and earthquake. So one scenario is during COVID-19, a large-scale flood happened, and another scenario is earthquake occurred during COVID-19. And in this situation, what would be the behavior of people or their decision-making behavior that will be discussed in the paper. The research gap that addresses in the paper are, since we know that during COVID-19, there are physical distancing required to maintain to avoid COVID-19 contamination, and also some behavioral change occur among the people. So all these different issues are addresses in this paper. The first writer of the paper is Noada. And the data collection procedure of the research was the researcher used Higashi Mikowa region of Japan and their municipalities and talked to the officials regarding the evacuation plan. Also, they performed a web-based survey on 500 residents of that region. The variables they consider for the survey questionnaire are age, gender, household size, and they consider three generation or two generation families. Also, if the person has cars or pets, they have vaccination or not, and also regarding some questions regarding COVID-19 fear. Actually, there are two models developed, one for flood and another for earthquake. And nested logic models are developed for flood. Firstly, uh, if people are interested about evacuation or not, consider then if they like to evacuate, then what is their destination choice was modeled. For earthquake, firstly, check for the if people want or evacuees want shelter or not. Then they consider what is the shelter location the person or the individuals want. And the most interesting facts or things are written in the paper. One is impact of the pandemic. We observe that the capacity of the shelters are reduced. It's almost reduced by almost two-thirds due to requirement for physical distance maintaining, and and there is a significant change in evacuees decision making. Their behavioral shift is observable. And most importantly, evacuation shelter capacity ESC index, which I will explain few minutes later, uh, is not substantially improved. And severe capacity constraint observed in that region of the Japan. And one of the most important thing that I discussed a few minutes ago regarding the behavioral shift, the study revealed that the young people are more interested about evacuation shelter than elderly people, except the 60s age people. And the person who fear COVID-19 are more likely to seek shelter, and unvaccinated people are less likely to use or to go to the shelter. And large size household prefer to evacuate because they fear COVID infection. And owners, especially the pet owners, the people who have pets, they prefer to stay within car. Within car near shelters. And there is a ESC index mentioned in the paper, talked about the mapping risk. The ESC index is the ratio of number of evacuees to the shelter capacity. This index will be used for the microsimulation, was used for the microsimulation of Toyohashi city of Japan, and create a hazard map. Using that hazard map, city planners, town planners uh, can identify vulnerable locations, and they can allocate resources, supplies accordingly. Another important facts of the paper is policy mindset, innovative policy mindset. The paper suggested to change from traditional attitude regarding evacuation plan to the dispersed evacuation plan. The paper proposed staying in hotels or designated safe parking places, also encouraging to stay in friends and family outside the risk zone for evacuation. That will reduce pressure on the existing evacuation shelter. And some of the research extension of this paper is we can extend this research for other cities, especially for developing countries like Bangladesh, India. And the survey data set was only 500, so large scale survey can be performed so that new variables and new insights regarding this evacuation model can be identified. And some of the valuable variables can also be understand through large scale survey. Another extension of the research is regarding dynamic model. Since we know that the evacuation behavior is dynamic, it changes within few minutes or within mid evacuation plan. So multi-stage choice model can be considered. So the sequential or flexible decision making can be incorporated in the model so that we can accurately predict the evacuation decision of the evacuees. And some features can be integrated with this research. For example, we can simulate traffic so that identify bottlenecks and congestion. Also, logistic supports such as food, water, and sanitation supplies can be incorporated with this model. Also, assess risks for other type of infections like Ebola and influenza, and some natural disaster like wildfires and tsunami situation can also be assessed the way or the framework presented in this paper. And real-time data can be used. For example, we can take the help of IoT traffic updates through Google apps or any other apps, and social media analysis can be performed so that we can manage disaster dynamically. And the main contribution of this paper during the COVID-19, how people or the evacuees behave if there is a natural disaster like earthquake or flood occur. Overall, the paper provide a new mindset and analytic assessment uh, like ESC index to map hazard, to create a hazard map so that disaster management can be more effectively done. And thus this research is a pathway to save millions of lives and support development of disaster management system. And that's it. And this is the reference of Noda et al. Uh, Thank you so much. And that's all about my presentation.